Welcome back. In this video, we will learn about organic chemistry. Specifically, we'll learn how to classify molecules as being alkanes, alkynes, or aromatic. Let's begin by talking a little bit about organic chemistry in general. It's really amazing to see how many different molecules there are that we classify as being organic compounds. Organic compounds are ones that are based mainly on carbon, but they also tend to have a lot of hydrogen, nitrogen, oxygen, and some phosphorus and sulfur. There are over 10 million different organic compounds that have been discovered or created. And here I wanted to highlight some of the largest ones that we know of. One is a protein called titin. This protein has over 160,000 carbons, 270,000 hydrogens, 45,000 nitrogens, 50,000 oxygens, and almost 1,000 different sulfur atoms. And this is just one molecule. It weighs 3.8 times 10 to the 6 grams per mole. That's massive. But it's really nothing compared to the size of what's called PG5. This is the largest human-made molecule. It weighs almost 100 times more than the largest protein, and it has 15 million carbon atoms and 40 million hydrogen atoms. And here you can see this little image. This is one monomer, one unit, and there's 170,000 of these bound together to create PG5. It serves no useful purpose as of right now. I believe that it was just made just to see how big we can make things. But even that pales in comparison to the size of our chromosomes. These weigh 100 times more than PG5. And so really we scale the gamut from teeny tiny molecules like methane, which is CH4, to our DNA, which is billions of grams per mole. And in order to talk about these organic structures, we need to remind ourselves of how we represent them. So we use what are called skeletal structures most frequently because it simplifies the structures, makes it a lot easier to see what's going on. This is also sometimes called the carbon backbone structure. And in these structures, the carbon atoms and hydrogen atoms are bound to each other in this, but they are not explicitly written out. Carbon atoms are indicated at the points. So in this molecule, we have 6 carbon atoms. 1, 2, 3, 4, 5, 6. And then also, using the idea that carbon makes 4 bonds, we know that there are hidden hydrogens here as well. And so we add on to this structure a number of hydrogens such that each carbon ends up with 4 total bonds. Now, if we had non-carbon and non-hydrogen atoms in this molecule, they would be shown explicitly. So for this particular one, we've got 6 carbon atoms. And then to see what it would look like if we showed all those hydrogens, it looks like this. Okay, you can see that each one of the carbon atoms has 4 bonds, and the number of hydrogens is added onto those carbons such that the total number of bonds per carbon is 4. All right, so let's talk about different classes of hydrocarbons. We have alkanes, alkenes, alkynes, and aromatic hydrocarbons. Alkanes are molecules that are classified only by having single bonds between the carbons. We also refer to this as being saturated, and that means it has the maximum number of hydrogen atoms attached to that carbon backbone. There's no rings, there's no double or triple bonds. Alkenes have 1 or more double bond. Alkynes have 1 or more triple bond. And then finally, we have aromatic hydrocarbons. And these have alternating, they're rings that are alternating double and single bonds within those rings. And this is another example of resonance. You can imagine that you could have drawn this molecule a different way where the double bonds have been shifted slightly. Got one there, and one there. And so these are two different imaginary representations of what the real molecule looks like, which is the average of them, where instead of having double bonds, we have partial double bonds that exist throughout the entire molecule. We also need to know how to talk about organic molecules. There are 10 prefixes that are used to describe the molecules depending on how many carbons long they are. And you'll notice this is only then useful for ones up to 10 carbons long. But those prefixes are pronounced meth, eth, prop, but, pent, hex, hept, oct, non, and dec. And so we can combine these prefixes with the suffixes we already learned to describe different molecules. For example, this is ethene. It has 2 carbons, and it is an alkene. This molecule is 1-pentyne. It's 5 carbons long, and it's pent. It has an alkyne. And the number 1 is indicating that that triple bond from the alkyne starts at the first carbon. Then this molecule has 10 carbons and is an alkane, so this would be called decane. All right, now let's let you have a turn trying to determine the identities of different molecules. For each of these 4, try and name and classify them. Pause the video and see if you can figure this one out on your own. Welcome back. So let's go through these one by one. First molecule has 4 carbons and a double bond. That double bond is at the first position. Therefore, in order to talk about it, we know that it's a but, and it's an alkene. 4 carbons for but, and it's an alkene. So this would be butene. Then to make it unambiguous where the location of that double bond is, we call it 1-butene. For molecule B, it has 4 carbons and only single bonds between them. So it also uses the prefix but, but it's an alkane. So this would be butane. Molecule C has 3 carbons and a double bond. 3 carbons means that it uses the prefix prop, and it's an alkene. And so this would be called propene. Now, you might be wondering, do we need to call this 1-propene? It turns out that it doesn't, we don't need to use the numbering system here because it wouldn't matter. It's unambiguous where the double bond is. It can only be in one significant location. If we put the double bond here, you notice we could just change our numbering system. If we here had 1, 2, 3, and then this was 1, 2, 3, it's really just the same molecule but flipped around. And so we only use the numbers to name if it's if there would be some confusion, if the location would make a different molecule. So for example, A, if the double bond were in between the second and the third carbon, then that's a completely different molecule. All right, now D. This is 3 carbons and a triple bond. 3 carbons uses the prefix prop. Triple bond means it's an alkyne. So this would be propyne. And similar to D, it doesn't matter if we were to draw the molecule like this. It's the same molecule, just rotated around. So we don't need to use that numbering system. That's it for this video. Thanks very much for watching. Have a great day.